Go over the Verilog interview question. This website's called EDA Playground, where you can quite easily compile Verilog. You can just choose all sorts of compilers on the left-hand side. So here I'm going to go to my playgrounds, and as you can see, I've kind of practiced a lot already as interviews coming up. So I'm going to click on this. This is called FIFO Practice Again, because I practiced this a couple days ago and just practiced this again. And the whole thing with technical interviews, you have to understand is that it's not really an indication of how well you perform as an employee. It's sort of like a Ponzi scheme where there's kind of no value, but if you pass, they give you a lot of money. So that's kind of how it works. So that's kind of why you need to practice, not really to hone your skills per se, but so that you pass the game and they give you money. It doesn't really mean, if a candidate does very well in interviews that they'll be a good employee, and it doesn't mean that they do poorly in an interview that they necessarily will be a bad employee. Yeah. So anyway, this is just this is not the problem that I'll be going through. I just open this so I can copy it and create a new template, and I'll just say weird problem. I don't know what problem I'm going to solve currently, but I'll probably write it out. I don't know all the specific details, but I'll write it out. So the reason why I like doing this is because on certain platforms like CoderPad, they just give you this. So I'm just trying to replicate the environment. In EDA Playground, you can actually have your design on the right-hand side and your test bed on the left-hand side, which makes a lot of sense. But on CoderPad, since the creator of CoderPad just wanted mainly to do headless Eclipse for software, he didn't really have considerations of like, design files versus test bench, because they're actually two pretty different things. So I actually like this layout better, but for practice, I'll do it one flat file, because that's going to be the interview environment, and you don't really want to stray from the interview environment if you're going to practice for interviews. Again, we're here just to practice for interviews. We're not really here to gain any skills, unfortunately. So the problem I want to do is, if I wanted to test a candidate on certain specs, like if they can read specs, and if they can implement it, if it's a simple enough spec in a reasonable amount of time. And this is, I believe, something similar that I got from Google. So suppose 1 bit at a time to a module. I want to see an output of 10 bits where top 2 bits, like 9, 8, are status bits. So the topmost, so the 10th bit, 10th bit will be indicative of the XOR of, let's say, the first 6 bits of the most recent 6 bits that's streamed in. And let's say second topmost 9th bit be indicative of if the sum of the first 4 bits, if the sum of, let's say, the yeah. So if we're streaming bits, let's have a contrived example. I might have 0, 0 if, let's say it was, I'll just make up some random value changes I need. The XOR, the first 6 bits, this will be 0. Okay, which is correct. And then is this plus this exceeding this? No. So, sorry, if I were to stream in these bits, then in other words, output all zeros unless at least one of the status bits are set, right? But what if I were to do, let's say, like stream this in and then it's like this, right? Then output, the XOR first 6 bits is still 0, but then 14 is going to be more than 2. Oh, sorry, 3 plus 2 is going to be more than 2, so this will be a 1, for example. And then in this case, you don't want to mask out the ladder bits. Need a 10-bit output, which is the status bits concatenated with the 8 most recently streamed in bits. Okay, and then I'll put this one. And if I were to do something, then it'd be like that. For example, and then for completeness, I want to come up with a case where it's 1, 0. So this will be, let's say, if I were to do like, yeah. If my input is 0, 0, 0, 0, 1, 1, right? And I'll just call this module a cipher because I don't know what it does, right? And then the question you might ask is, well, is there any parameters? Not really, because this is kind of a fixed problem, and you know a priori that there's your width is 8, so you're just gonna do this. I like writing the module out first, like so. So you need, clock reset n. You want to do negative reset because that's best practice. Is chips start without power, so yeah. And then you want to also bit. So this is the bit that you're streaming in. Bstream. I always misspell bitstream because I'm dyslexic, so I'm not gonna waste time doing that here. And then I probably want to have an enable signal. So like, what if I want to turn off the bitstream? Then I'll just qualify. So basically, the bit is only valid, if enable is valid. And then I want to output a 10-bit signal, which is just going to be the, I don't know what I'll call this, vector. I'll just call this out, okay? And then I'll close off the module here, and then I'll do, I like instantiating this, but I don't know if it's, yeah, I like instantiating this because if the interview is going to have a test bench anyway, I might as well, like you're going to have a test anyway, so I might as well just do all the boring parts first. Bstream, this can actually go together, and then logic. 9,0 out, and then cipher okay, clock reset, n is not of reset, and then your B stream is going to be B stream, and then your enable signal is going to be enable signal. Maybe I can make it a little bigger. And yeah, let's start with clock 0, reset equals 1, and B stream is 0, doesn't matter, and then enable is 0 just because we're starting the machine. I want to make sure that this doesn't fail, and it doesn't. Let me make this window smaller. Yeah. So it compiles, which is good. So if possible in an interview, I would just run this to make sure it compiles. So, because like if you make like one small character mistake, you don't want to be tripped up later on. If you're debugging, you don't want to know, like, you don't want to have the fatigue of like, hey, it's just a syntax error, or to actually make a real logical error. So here we kind of rule any kind of syntax errors out the way. So the spec is saying that, well, first, let's define some stuff. Reset n. Now, some interviewers like and if it, so one sec, logic 9,0 mem. Let's say it's a one-liner like this. Some interviewers would prefer you just to do this, but my counter argument is like, I don't want to be too clever if I'm writing actual production code. I'd much rather wrap it with begin end, because if someone wants to, add an extra line here later, they don't have to like wrap in begin end. Like, it doesn't add anything if you just simplify the code with begin end. Like, yeah, like a toddler would know how to read begin end. So yeah, during an interview with Apple, they were like super anal about it, and that's kind of how you know you don't want to work there. All right, and let's begin. So what is this mem? So basically, you can end else if enable, but I like end else begin because later on, for maintainability reasons, if there's like non-reset conditions where you have to have multiple branches in, here, you can just easily add if else statements without having to mess with the main reset structure. So it's just kind of preference, but either answer is right. All right, so if enable, then you can do that's probably a bit cleaner. So you want to just do like a shift. So it's like a 6, 0, and then you want to shift in your B stream and N, and N is redundant because you're not going to shift in anything. If this isn't enabled, and right, so 1, 2, 3, 4, 5, 1, 2, 3, 4, yeah, this output's on, assign it. So that's kind of all you need to do for keeping track of your 8 most recent bits. So then, what did I say this was? Top status bits is if you're to XOR. Is it the XOR or what? Yeah. So here you can ask your interviewer a question. which is, do they want this result in the same cycle or they want it in the next cycle? So for example, if they want it in the same cycle, then you have to do the right-hand side here. And then you would do and here, right? Otherwise, it's not, enabled. And also another question, I guess I need to define is, what if enable is off? Do you still output your status bits? I would say for this question, let's just keep it very simple. So let's have the status bits come one cycle after you stream it. So I'm not expecting, like I'll give you a one cycle to calculate the status bits, basically. Okay, so but if it's the same cycle result, then you would just use right-hand side instead of left-hand side. And then if the enable, like how I would do it if I made a candidate do it on the right-hand side, is like, oh yeah, if enable is 0, just force the entire output to be 0. So then your output could just be, 10 enable and then and with whatever, right? But here, let's just keep it simple. Let's just say that, because this video is long enough probably, this is just gonna be the, like that, sign bot. Do I call it bot or bottom? I'll call it bot, and what is it? It's the sum of these two exceeds, okay. One thing I'm not sure of is whether or not, like if you do A plus B, the carry over actually gets carried over. So I'm just gonna implicitly cast this to 3 bits per each. So for example, this is 7, 6. Yeah, 5, 4. If this exceeds, so this hopefully should compile a 3-bit thing. Exceeds well, actually, because this is going to be a 4-bit comparison on the right-hand side, so strictly exceeds, right? So then you just do mem30, and then lastly, is either of these bits set? If not, 0. If yes, then do top status bit, bot status bit, and then mem. This isn't mem, this is output, actually. So let's see if this compiles first before I put any stimulus in. Okay, that was quite miraculous. And then maybe something you could do here is like print and clock. Right, and then begin, end, and task. And then I kind of want to display some stuff. But what do I want to display? I probably want to display my bstream. And I probably want to display whether or not I've enabled some stuff. And I probably want to display the internal memory. Obviously, I would like to display the output. And yeah, so let's just bstream enable cipher dot memory, and then I cipher dot well, actually, yeah, well, output should be on the top level, So that's what I'm missing here. All right, so this is on reset state, so it's not like I care about the answer. I just want to see if this compiles. Okay, great. So reset is 0, and then let's say bstream is, let's try to do this actually. Okay, so let's say this one is that, test 2 is like that, and test 3 is like this. Then so I do want to clock it, but I want, if I give a new input, I guess I don't care what's happening in the cycle. I actually care about what's happening in the cycle after. So when I write this like print and clock statement, I can put the display before or after this clocking thing. And in this case, I'm gonna just put it after because I put a bstream in and I don't really care until a cycle after what the memory and the output of the file is, or the module is. So yeah. So reset 0, and now for int I equals 0, I less than 8, I plus plus, begin end. Bstream is test1 I, and then yeah, I think enable must be 1. And then print and clock, and then let's see if there's any bugs here. Probably prefer this actually. So first is the memory so 1, so 0, 1, 0, 0, 0, 1, 1, 1. Oh, I actually want to shift it in the other way, and I don't want to shift it in this way. So actually, wait, do I? So shift in a 0. And then I shift in the 1. How come? So I'm not gonna, so I'm gonna clock this, right? Reset, and then if reset is 0 and my enable is 1, then should be shifting in a 0. But I don't know why I'm not shifting in. Oh, I see. This is the 0. I see. I guess I meant for this to be the oldest and then this to be the youngest. So so I'll just do this instead. Yeah. Actually, there's only 7 through 0, so actually like this. Let's see if this gives me the, yes. Yeah, so yeah, okay, cool. Right. So what's the answer here? When we get this, do we get 0, 1? Yes. And here it's quite nice. You can kind of check everything in between. So here we have 1, 1. So it's 0, 1, 1. So the XOR is 0, 0. And as long as it's shifting at 0, this one will remain static. And when this is shifted into the upper 4, then we have 1, 1, 1 is 1, 1. So this is also 1, and we have 0, 1, blah, 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 blah. Okay, cool. So let's repeat it for test 2 and test 3. Test 2 is 1, 1. Yeah, test 3 is 1, 0. And I'm kind of curious, like, what if, so 1, 1, 1 plus 1, 1, 1 is 14. So what if I did like, all ones, which would be not 14, 6, and I did 5 here. Would that give me a 1 on the final answer? I was trying to test a case where it's like gonna carry over. Yep. And the first 6 bits, there's 4 1, so the XOR is 0. And that basically wraps up this problem. I mean, if Canada did this, I'd be pretty satisfied. Yep. See you in the next one.